I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 11th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and smash the like and subscribe button. You'll get automatic notifications when the videos are posted, typically on Sunday night. And here we go again. Next Sunday, there will not be a video. This is probably the last Sunday that we'll do this, but there's something come up. I need to go take care of it. So there will be no video, but the week after that, for sure there will be. And about that time, things should start getting pretty interesting in the long-term outlook. All right, let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a gale almost outside the California swell window. The cutoff's about 117, 118 west, so right there. This is actually secondary fetch from a gale that was in this area a couple days before. Still producing seas in about the 35-foot range, and some sideband energy likely is radiating north, targeting mainly Southern California, a little bit of energy perhaps going to push into Northern California, and certainly Central and South America. All right, let's go take a look at the jet stream. And here we are, jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a push in the jet to the north, right like there. And this is the southern hemisphere. New Zealand there, Australia there, Antarctica down here. The Ross Ice Shelf, or all Antarctic ice, towards its peak, if not at its peak, that is encroaching further to the north since it's the dead of winter there at about 62 south. That provides a lot less aerial coverage for storms and the winds in storms to get traction on the ocean surface. So typically this time of year, things start to slow down in the South Pacific. But as of right now, that doesn't appear to be the case. Right, we have a trough. It's pushing to the north. That helps create a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough to get traction on the ocean surface, create seas. Seas, as they radiate or propagate away from the fetch area, groom themselves out, eventually turn into swell. Swell, when it hits your beach, turns into surf. So we have a trough. Everything starts in the upper atmosphere with a trough. We have a trough in the Southeast Pacific, and we saw from the previous chart that there are seas being generated in this area. But as you can see, as we move into Monday, September 12th, the trough starts pushing east out of even the Southern California swell window, and a ridge, the exact opposite of trough, where the winds start pushing south, in this case, over the Ross Ice Shelf and Antarctic ice, right about the cutoff is there, into Antarctica proper, and all that does is create this sort of split jet stream flow, the southern branch down here, northern branch up here. High pressure sets up in between. That does nothing for producing surf. So kind of a down day for Tuesday and Wednesday, but then later on Wednesday, a new trough is forecast building under New Zealand with 140 knot winds. The stronger the winds over on the west side of the trough, the better the chances for southwest winds pushing north up towards the Hawaiian Islands in California. That's in our swell window, and therefore the better chance for producing surf. That trough kind of pushes east, reorganizes a little bit on Thursday and Friday, perhaps generating some sort of secondary gale down at the ocean's surface, even into Saturday, moving towards the Southeast Pacific as we get into Sunday with a new ridge building down. Now, it is the middle of September. Typically, we are looking at the northern hemisphere. Certainly by this time, one would think there would have been some small north swell pushing into exposed breaks in Northern California and the Hawaiian Islands, but not nary a hint of energy and none in the immediate forecast. So we're focusing on the southern hemi, and there is plenty going on there, so why not dig into it? Next up, surface level pressure, surface level winds, and as expected, there's a gale in the Southeast Pacific right there. Again, New Zealand, Australia, Antarctica, South America right there. The gale had 35, 40, maybe a pixel of 45 knot winds, and the cutoff for Southern California, again, 117 west, so right about there. So there is fetch in the swell window. We know there are some seas being generated. A tertiary fetch is forecast developing as we get into Monday, producing a little area of 45-knot winds aimed north, and that might generate some seas, so there's some hope there. And then we also see a new gale forecast trying to develop under New Zealand. First, a primer gale, 40-knot winds pushing to the north, if not northeast. That will certainly rough up the ocean surface. And then a much broader gale starts building as we get into Wednesday, the 14th of September, with 45-knot east winds pushing under New Zealand, pretty well on the Great Circle tracks to Hawaii and certainly to California, with a building area of 45-knot winds as we get into Wednesday proper, continuing through the day, lifting sort of northeast, then starting to fade on Thursday. There is still fetch, but you see it's 35, 40-knot winds, all aimed to the southeast into Antarctica. Penguin storm there, no hope. Now, maybe another fetch on Friday develops, 40 to 45-knot winds. The cutoff is somewhere right along here, the ice line cutoff. So that's in a good position. It moves rather quickly across the South Pacific into Saturday and even into Sunday with 35-knot winds, offering some potential. All right, let's go take a look at the effect of these winds on the ocean surface. But first, we're going to go back in time. We're back to Sunday, the 4th of September, a week ago. A gale developed under New Zealand with 28-foot seas, building a little bit with maybe 32.5 feet seas exact. These are the highest. This line down here depicts the highest winds and the highest seas over the entire domain of this image. So, in this case, it happens to be right where we want it to be, in the California and Hawaii swell window, 32.5 feet, then lifting northeast, fading. This was into Monday last week. Then some additional fetch developed, but all aimed off to the southeast and of no real interest. Yeah, 38-foot seas or whatever, and a little bit of it, perhaps it suggests aims off to the east, but we're pretty much figuring for the most part, it's all pushing southeast. I mean, the fetch itself is falling southeast, so we don't expect any real swell to develop. Then on Thursday, September 8th, another gale developed right off the edge of the Ross Ice Shelf with 26, maybe 27-foot seas, building to 28 feet in pockets later Thursday and early Friday, and then developing a little more with 32 or 34, 30, 32, and we'll say 34-foot seas in the Southern California swell window, most of it aimed off to the east, maybe a little bit of sideband swell expected to push off to the north. And then the secondary fetch that is occurring now, this is actually started Saturday night, producing, again, 37-foot seas in the California swell window. But again, with that strong easterly push, very little energy expected to radiate north. And that gets us to where we are right now. So that was all hindcast data. That is what the model's best idea of what actually was occurring. Now we go look at the forecast, a projection in the computer's mind of what might happen. Notice most projections, or for those of you that watch these videos, know that after about 3 or 4 days, the models really fall apart. They cannot really resolve what's going to happen 5, 6, 7 days out, much less 2 weeks. Sometimes they get lucky and do okay a week out. If the atmosphere is very stable, if a strong storm is, and a storm track is in effect, then they get lucky and they score. But most of the time, 4 or 5 days is about it. Anyway, we're getting into Monday. Here is that tertiary gale that's forecast producing, 28-foot seas off to the north, mostly out of the California swell window. And then come Wednesday, the main event, a gale forecast under New Zealand with seas right now pushing forecast to 38.6 feet to 40.4 feet. Let's see, do we get another reading out of that? 41.4 feet. This morning's models had a little bit broader area, 40-foot seas, but still pretty much in the same ballpark, and only 90 hours out or left. So we're only 90 hours out. So we're within the 3-day window, more or less. So seems like there's good probability some sort of gale will develop, and certainly some swell could result. As we get even into Thursday night, still 30-foot seas persisting over the southwest Pacific. And then a secondary gale forms after that, producing 30-foot seas, maybe a little bit more, certainly 29 to 30-foot seas, pushing the whole way across from the south central Pacific into the southeast Pacific, into Sunday, a week out, and then fading from there. So a pretty good run of swell is already in the water, and it looks like 2 more are forecast. Wind projections, well, we're in the Indian summer time frame. Typically, the north winds and wind swell potential starts fading for California, and you see that here. Really no solid high pressure in the image at all. If anything, bits of low pressure here and there. Seasonally, that would be about right. But in a normal year, you would actually have far more low pressure activity in the Gulf of Alaska, or at least out by the dateline, but we have none of that. We're looking for any hope for wind swell, or actually we don't really want wind swell. The southern hemi swell is coming north, and we don't see it. Light trades for the Hawaiian Islands, the typical, we'll call them trades for California, northwest winds, maybe 15 knots, most of it focused south of the Golden Gate. We're into Tuesday the 13th, nothing. Wednesday, Thursday, pretty calm pattern, but then something kind of interesting happens as we get into Friday. Low pressure, very weak, but it starts building off of Oregon. Not that it's going to generate anything, but just the fact that there is low pressure, and you can clearly see the flow, the counterclockwise flow. Low pressure in the northern hemisphere flows counterclockwise in the southern hemisphere clockwise, generating a fetch, maybe producing some wind swell aimed at Hawaii, but nothing at California proper. No real weather is expected, but still low pressure nonetheless. If anything, maybe some south winds along the California coast as we get into Saturday and certainly Sunday of next week, a week out, and a little bit of stronger south winds at maybe 25 knots for Cape Mendocino for a brief moment in time. But we'll see how this all plays out. Give it a couple more days. And since there is low pressure forecast, let's see if it actually produces any rain. We see the typical monsoon rainfall pattern over the Sierra as we get into Tuesday and Wednesday. That low starts organizing somewhere around, Thursday or Friday. There we go. You see it rain off the coast in the gradient between high pressure offshore and lower pressure near shore. There's the gradient. There's fetch that aimed somewhat at Hawaii and rainfall. But we're looking to see if any of it moves into California. And there we go. Just a smidgen over extreme northern California. We'll say from, maybe even Bodega Bay northward, and quickly moving north, and that's a week out. Odds of that happening are almost non-existent. And then looking at the freezing level, we're going to do this at the Pacific Crest Trail where it crosses with Tioga Pass Resort or the Tioga Pass Road. And this is looking up in the atmosphere from ground level the whole way up. If it is red here, it is above freezing temperatures. If it's the gray, we can see 32 to 35 degrees. That would be like sleet if there were precipitation. And then at 32 degrees, this hard white line where the blue is, that's freezing. Interesting, the freezing level has been at 14,000 feet or higher for months now, typical of summer, and just today it started dipping down to about 12,500 feet, and is forecast to hang somewhere between 12 and 12.5 for pretty much the forthcoming future. That suggests that maybe a hint of fall is in the air. Maybe this will be driven some by that low pressure system off the coast, and maybe some of it is just a seasonal change, but still, temps pretty warm in the Sierra, nowhere near getting to be winter yet. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation, and of course the El Nino Southern Oscillation. As usual, we start by looking for signs of the MJO, the Madden Julian Oscillation, a periodic weather oscillation that has two phases, active phase and the inactive phase. The active phase on one side of the planet, the inactive phase on the other. They rotate from west to east on the equator, opposing each other. The active phase is essentially a low-pressure system, and that low-pressure system, when it moves over the Pacific and also over the Indian Ocean, helps to impart energy to the jet stream, but specifically when it's over in the western Pacific on the equator, it imparts energy to the jet stream, which feeds the storm track across the North Pacific and the South Pacific in winter months. It also dampens trade winds, if not causes them to reverse. That, in turn, can take warm water that's over in the far West Pacific, pushed there by trade winds. If the trade winds weaken, that warm water then gets the opportunity to slosh to the east. If you have successive active phases of the MJO pushing over the Pacific, they create what's known as Kelvin Waves. The pockets of warm water from the West Pacific. They push under the equator the whole way to Ecuador and then erupt to the ocean surface there, warming surface temperatures in the East Pacific. Successive active phases of the MJO and successive Kelvin waves can be a sign or can help usher in El Nino, so we watch them intently. All right, so we're looking for signs of the active phase of the MJO. The inactive phase does the exact opposite, by the way. It's high pressure, sort of locks things down, enhances the trades, and doesn't do anything to impart energy to the jet stream, or if anything, it causes upwelling and cold water in the Pacific. All right, so data from the TAA buoy arrays, series of buoys strung across the equator used for monitoring El Nino. East Pacific here, West Pacific here. 0, that is the equator. That is New Guinea there. 180 is the date line. We're just looking at the arrows. They show 5-day average winds. The longer the arrow, the stronger the wind. So strong easterly trades in the East Pacific, same thing over the Central Pacific, and strong easterly trades over what we call the Kelvin wave generation area. This again is that area when the active phase of the MJO moves over here, it takes these trades, starts to dampen them, and these colors here are water temperatures in centigrade. Warm water here in the west, it allows that warm water to start sloshing east. But it's not the average wind speeds that matter, it's the anomaly, differences from normal for this time of year. Looking at the arrows here, you see the arrows from an east-west perspective, they're pretty much normal. In the Central Pacific, a little bit stronger out of the east than normal. Over in the important Kelvin wave generation area, winds a bit stronger out of the east than normal, probably moderately strong. We'll say this is a likely sign of the inactive phase of the MJO. So what's the forecast for the next week? All right, so we're looking at what they call 850 millibar zonal wind anomalies. That's just fancy words for are the winds stronger out of the east or stronger of the west. The blues mean stronger east winds, enhanced trades. That would be like the inactive phase, the MJO. The reds, stronger than normal westerly anomalies. That would be the active phase of the MJO. So go, oh, that looks pretty good, and that doesn't look so good. But we got to get ourselves oriented. This is the whole planet on one chart. The date line runs right up the middle of the chart. So it goes from 0 to, well, effectively 360 degrees. All right. The date line right in the middle, that's pretty much in the West Pacific. The far West Pacific starts about 135 east, so right here. This is what has been happening since August 12th. You see a preponderance of easterly winds. Looks like the inactive phase of the MJO. And another little point, if you get one of these long stretches of easterly anomalies like this and the MJO doesn't even look like it exists, then this is typically a sign of La Nina. Clearly we are in La Nina. So the good news, sort of, if you're reaching, if you're grasping, is, well, those easterly anomalies, the worst of it, were on September 1st, seems to be moderating a bit. This is just for the next week, next 7 days. And here's the main area, Kelvin wave generation right here. But still, easterly anomalies in control, westerly anomalies held at bay, can't quite get into the Pacific yet. So that doesn't look so promising. So let's go out 2 weeks, right? Don't believe a model out 5 days, so why would I believe it out 5 weeks? Well, I mean, out 2 weeks. Well, because when you're desperate, you make the best you can of what you have. All right, September 10th is the model run. Goes out 5 days at a time. So today, plus 5 days, plus 10 days, plus 15 days. And we see there's South America, Central America, Hawaii, New Guinea there, equator right there. Okay, date line right there. Kelvin wave generation area right here. We want to see, now this is outgoing long wave radiation. Fancy words for cloud cover. Looks like a neutral pattern right now. This per the statistic model. 5 days from now, same deal, neutral. 10 days from now, the yellows. What's plus anomalies mean? That means more sunlight reflectivity off the ocean surface. That means no clouds. That means the inactive phase of the MJO and building 15 days, 2 weeks from now. That's per the statistic model. The dynamic model doesn't pick up on that at all. It just says, no, we continue in a dead neutral pattern for the next 2 weeks. So that sounds reasonably positive. Then we drill down a little bit deeper. This is the statistic model here, the dynamic model here. These charts, they're called phase diagram charts. They show you where the active phase is and how strong it is, and a lot more accurately than the previous charts. So the MJO, how do you read this chart? The MJO moves from west to east, from the Indian Ocean to the Maritime Continent, into the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot right here shows you where the active phase is, and the further the dot is outside of this circle, the stronger it is. The ideal situation is the dot up like here somewhere in the West Pacific, just churning out Kelvin wave after Kelvin wave, but we don't have that. The active phase right now, it's in the West Pacific, but it is exceedingly weak since it's inside the circle, and the forecast track has it moving roughly somewhere in the area of Africa and still very weak 2 weeks from now. The dynamic model, pretty much saying the same thing. Africa, maybe not even that far, the far east Atlantic Ocean. So, in either case, both models suggesting a weak MJO pattern for the time being. So, if 2 weeks isn't enough, let's go out 40 days. This is the upper level model showing the propensity for precipitation. The greens, areas favorable for precipitation. Yellows and oranges, dry air. Basically, yellow and oranges, inactive phase of the MJO. The greens, active phase of the MJO. And let's get ourselves oriented here. South America, Central America, New Guinea there. 0 is the equator. Dateline roughly right there. So the area we're really interested in is right here, the Kelvin wave generation area. There's 8 panels, each 5 days apart. So this goes out to about the 21st of October. We see the active phase of the MJO. In this case, over this model, this is a statistic model suggesting maybe more like over the Indian Ocean, trying to bleed into the West Pacific, let's say towards the middle to end of September, September 21st, and then making its way across the Pacific into about October 8th or something like that, and then falling apart, and it is a very weak sort of fragmented active phase. And then the inactive phase, equally as weak, makes its way into the Pacific through about the middle of October. So no real hope there either. So then we go to the CFS model. This goes out 1 month, start today's or yesterday, September 10th, out to about October 8th. Right, same deal, whole planet on one chart. Date line running right up the middle. Far West Pacific starts about 135 east, so right there. Okay. Past performance, you can see just this, and this is east-west component of the wind. The blues are easterly anomalies. The reds, westerly anomalies. Now, these lines here, the solid contour is the active phase of the MJO. You can see an active phase of the MJO tried to enter the Pacific in late July, early August. It hit this La Nina base state, got destructively interfered with, and basically got wiped out. The westerly anomalies associated with it died right there. The inactive phase of the MJO did the same thing in middle to towards the end of August, and it died, but you can clearly see it enhanced easterly anomalies, so it constructively interfered with the La Nina base state, creating enhanced easterly winds. Here's our next active phase of the MJO, trying to make it into the West Pacific. It's supposed to get destroyed by La Nina, and there's what's left of it when it pops out the other side. Notice the La Nina real influence area is exactly the same as the Kelvin wave generation area, from 135 east to about 170 west, and just no show. And then an inactive phase is forecast after that. It again will constructively interfere, or the amplitude of the inactive phase, or the cycle, or whatever you want to call it, of the inactive phase and La Nina, they join together and they enhance each other, whereas La Nina and the active phase cancel each other out. You can see it making its way across the Pacific into the latter part of September into October. But beyond that, things are supposed to get a bit interesting. So if a month isn't enough, let's go out 3 months. Totally believable. Completely. I know, everyone's laughing. But you take what you can get. All right, so this is the same deal. The whole plan on one chart. Dateline runs right up the middle of the chart. Yellows and oranges are westerly anomalies. The blues, easterly anomalies. Now, this chart, past performance is down here. So May, June, July, August, September, October, November, into December. And you can see, at least according to this projection, easterly anomalies, we saw it on the other chart, into October. But notice that, where's the date line? The date line's right there. And notice they start sliding off to the east. And when that happens, the westerly anomalies that for 2.5 years have been balled up over the maritime continent are theoretically forecast to start sliding east and effectively filling the Kelvin wave generation area as we get into December, if not earlier. Let's overlay the MJO to just see what's going on. All right, solid contours, active phase of the MJO. Here's our current active phase that's trying to push into the Kelvin wave generation area, right? The Kelvin wave generation area is from about here over to about here, so right in here. And it pushes east with time, fades, but it sort of nudges the easterly anomalies off to the east a little. There's an inactive phase that's supposed to follow as we go from mid-September into the early part of October. But you notice easterly anomalies, they build, but they're more like out by the date line and not over in the Kelvin wave generation area anymore. And then this active phase of the MJO, and this is kind of key here, it's supposed to push into the Kelvin wave generation area maybe the 5th of October. And when it does, it starts dragging westerly anomalies, the good anomalies, the ones that help feed energy to the jet stream and possibly create Kelvin waves, starts pushing east. And by, we'll say, almost Halloween, the entire Kelvin wave generation area is to be free of easterly anomalies with light westerly anomalies or neutral winds in control. If this were to happen, this would be a significant change because we haven't had something like this in, 2.5 years, however long it's been. All right, let's overlay the low-pass filter and get a sense of what's going on. Now, this is the little bit perplexing part because at the surface and near surface, we have westerly anomalies going, but there's this high-pressure, low-pressure bias thing. We call it the El Nino, La Nina indicator. The dotted contour is a high-pressure bias. You can see it here, locked. It's been over the date line and is forecast to hold, at least as we get into November. But you can see the western edge of it. If anything, retrogrades a little bit west, but then starts making some eastward progress. The low-pressure bias, the El Nino indicator, has been over the Indian Ocean and the Maritime Continent for 2 years now, and that's where all the action has been in terms of surf. But you could see the leading edge of it trying to make some headway off to the east. The real question is, will these westerly anomalies actually develop? Well, we'll know as we get into about mid-October, because then we'll be in the window where a lot of this is going to be believable. This has been on the charts, though, for 2 months now, and it really hasn't wavered much. So at least at this very early date, it's semi-believable. And there's some other data that sort of supports that. So let's get into that. So let's go take a look into the ocean and see what's going on. Not at the surface, but down deep in the ocean, down 200-300 meters. That'd be 600, 900 feet or more. All right. We have data from the TAO buoy array. There's some same series of buoys strung across the equator. And these are the anchor lines on those buoys. The X's are sensors on those anchor lines. They collect temperature data down into the ocean, and that is used for monitoring, approaching, and developing Kelvin waves. Warm water pushing off to the east. This is the West Pacific here. This is the East Pacific here. All right. And you can see, well, this is the 28-degree isotherm. That's 28 degrees centigrade, which is warm water. Okay. It is, the leading edge of it is at about 170 east. I think that's about where it was last week. The 26-degree isotherm right here, it actually backtracked to something like 157 last week. It's making some eastward progress now at about 147 or something like that. And the 24-degree isotherm, which was way back at 140 maybe a week or two ago, it has made significant eastward progress. Maybe it's just the model, because you can see the big gaps here in between where the sensors are, and the model has to sort of make up what's going on. All it has is these series of sensors to feed it, and a series of rules telling it, well, what to do if and then and when and all that sort of stuff. So, but at least according to the scant data available, this suggests the leading edge of the warm water is pushing back to the east some. That's kind of good news. But it is not the actual water temperatures, it's the anomaly, differences from normal for this time of year. We see warm water in the West Pacific, as it has been, with its leading edge at, what's that about? Well, that's 150, so we'll say about 153 west, something like that. And cold water upwelling water, the upwelling phase of the Kelvin wave cycle, if not La Nina, 3 degrees below normal, pretty much locked exactly where it was last week and the week before that, suggesting this steady state cold upwelling pattern still unchanged as of today. Then there is this other depiction, same sort of general subsurface pattern showing you temperatures, but it's not using the TAO buoying array. It's using, or maybe it uses some of that data, but I think it's primarily using satellite data and the height of the ocean surface to sort of get a sense of what's going on deep down. You see warm water, much, much warmer than what was shown on the previous image, making it to, well, what's that? About 157 west, about the same position with cold water to the east. And if you saw, this is actually an automated image, but it's kind of hard to get it running here on the webcast. But the short of it is, this boundary, we're looking for the warm water to push off to the east. It hasn't budged an inch for weeks. Now here's the satellite data that model uses. All right, let's get ourselves oriented. South America here, that'd be Chile, Peru. Central America there, Hawaii right there, the equator there, dateline there, New Guinea there, Australia down there. It's the only area from 5 degrees north to 5 degrees south that really matters. You can see these positive anomalies. Oh yeah, so let's talk about what this really is. This is the height of the ocean surface. Jason 3 satellite data, or one of the other satellites beaming radar down, measures the exact height of the ocean surface compared to normal. Take out the wind waves, take out the swell, and take out the tides even. It's that sensitive. And is the ocean higher or lower than normal? Why would that be? Well, if you have warm water at depth, warm water expands. It'll create a bump on the ocean surface. Cold water at depth contracts. You'll get a divot on the ocean surface. And that's exactly what we see. A minus 15 centimeter divot, actually 2 of them right here at about 140 west, 120 west. 15 centimeters, that's about, that much, something like that. Not a whole lot, pretty sensitive, but it suggests cold water, there's a Galapagos there, off this whole area right here, just like the other images showed, and warm water off in the far west Pacific. It's probably, you can see it at least according to this from the height, it's limited to the far west Pacific. We think the dividing line is somewhere right around in there, and this sort of infers that, but not directly. So, knowing that, then this chart helps depict sort of in historical terms the past year. What has the balance of warm and cold water been in the upper 300 meters of the ocean for the past year? Okay, West Pacific here, East Pacific here. Last October, November, cold water, very cold water, in control of the East Pacific. Warm water, not very much of it, and held at bay in the far West Pacific. There was one pulse before this chart even started, the main one here in October, and another one in December. Then a Kelvin wave, that is, the active phase of the MJO pushed over the West Pacific, producing westerly anomalies, taking the warm water that was here, pushing it under the ocean surface the whole way across the Pacific. Kelvin wave, great, that was good news, but then another upwelling phase developed this past spring, March and April, and that was the end of that. Then we got 2 active phases. You can see lobe number 1 there, number 2 there, created a Kelvin wave, a rather weak one that made it most of the way across the Pacific. And then here we go back into the upwelling phase. Now, you see the fall upwelling phase here, really cold in October. We're not there yet. In fact, this current cold push is not as bad as the one in March, not as bad, bigger than the one in March, but not as bad as the one back here. But you can see these cold lobes just kind of hanging on. We want to see, you get this hint, the sense that it wants to push off to these, but there's just really nothing to dislodge it yet. We think the coming active phases of the MJO in the October time frame is what's really going to make this start to fade and help warm water, which you see is building in coverage, start to ease at least back to a normal position. And yet, one more view of the same sort of situation. Upper ocean heat anomalies, upper 300 meters of the ocean, for the area from the dateline to almost Ecuador, but not quite. Last fall's cold pulse, cold indeed, and broad and long-lasting. There was our one Kelvin wave that was in the February-March time frame. The weak cold pulse that followed, the most recent Kelvin wave in the June-July time frame, and now the current cold pulse that we're in, colder than this one, but not as cold as this one. And we want to see the bottom of this thing start to drift up, but we're not seeing significant changes as of yet. So then we take a look at ocean surface temperatures. What's going on down in the ocean and what happens at the surface can sometimes not be the same, especially if a Kelvin wave, warm water, is pushing across the Pacific. You won't see it at the surface. You could have cold water like this, and it could be cooking hot, a river of cold water underneath this, working its way across the Pacific. It takes like 3 months for Kelvin wave to get across the Pacific. All of a sudden, you'll see warming starting to develop here in the area of the Galapagos and Ecuador. And then the trades will pick that up, carry it across the Pacific. That is not the case right now. We know there's cold water at depth. We know warm water is trapped somewhere around here. So there is warm water here on the equator. Oh, let's get oriented, sorry. Chile, Peru, Central America, Baja, Hawaii here. The equator is where it really matters. We know warm water has made it to about this far, but no further. And then we know that the cold pocket subsurface really is focused between about 140 and 120, something like that right in there. And you can see that reflecting in the ocean. There's a little bit of cold water here off of the Galapagos. Most of it is right out here being caught by the trades, drifting off. This is the classic La Nina pattern. You have cold water, colder than normal water, does not support evaporation. If you don't have evaporation, you can't get cloud cover, and it just doesn't work out. We need warm water to develop over the Pacific. The trend for the past 7 days, all right, Pacific Ocean right here, South America, North America, Australia, New Guinea, equator. That's what matters right there. We're just looking in this area right here. We see pockets, this is just 7-day trends, pockets of cooler water, pockets of warmer water, sort of a mixed bag, neither warming nor cooling. Steady state cool, that's what all the subsurface data says too. That cool ball of water, which is really right around in here, subsurface, is stationary. Some of it, and it's not building any, and some of it's drifting off to the surface. But trades are a bit stronger than normal, but there's a lot of sun beating down on the ocean surface too, so just kind of a mixed bag. You can also see where, what was it, K made its way up the coast of Baja, created a bunch of mixing, wiped out warm water that was there in like a week, and it's colder than normal. Heating here, this is all heating from high pressure and a relatively light wind flow over the Hawaiian Islands. Same thing for the Atlantic, and where it was Earl here, pushed off to the northeast. You can see the upwelling there. So really not a whole lot going on. The backed off view, you can just see broad area, cooler than normal water, stable air above it, not doing anything to feed the jet stream, and just kind of, well, it's La Nina, right? Clearly, there are still storms in the southern hemisphere, nothing in the North Pacific. Typically during La Nina, especially when you're into like starting the third year of a La Nina, we're going to talk about that in a minute, then summer is a delayed start. Spring is cold and windy, which exactly it was in the Pacific, and then you get an extended summer. Winter takes a while to get going. We're clearly a month behind schedule. Not quite yet. We're probably 3 weeks behind schedule, but we're going to be a month to 6 weeks behind schedule before we expect anything significant to occur in the North Pacific, all driven by La Nina. Sea surface temperature trend in the Nino 1.2 area. This is the area right there by the Galapagos in Ecuador. You can see the trend, what is this, for 3 months or something like that. Today's value, minus 1.144 degrees. That's 1 degree and 144 thousandths below normal. The La Nina threshold starts at a half a degree. You have to be below that to be in La Nina. Well, clearly, this is not the official El Nino monitoring region, but even these Pacific temperatures colder than normal, pretty much stable, hanging right about 1 degree since, well, the end to middle of July, something like that. Then there's the official El Nino monitoring, the Nino region, the Nino 3.4 region, the area from a point on the equator south of California out to about the dateline. It, too, has stabilized. Today's value, minus 1.000. So a half degree below the La Nina threshold, clearly in La Nina territory. Been there since about August, I don't know, 17th or 18th, something like that. Not going up, but not going down any. So what does the atmosphere think is going on? Well, we know we have cold water filling the whole equatorial Pacific. One would suggest that would support high pressure over the bulk of the Pacific. So we have this thing called the Southern Oscillation Index. All it is real basic. In Tahiti, someone every day goes out and looks at the barometer at the exact same time, reads the value on it. And someone over in Darwin, Australia, reads their barometer. The information is shared. You can take it, and this is a long-running index. There's been people doing this in Darwin, Tahiti for 150, 200 years, something like that, something crazy. But you can take that. It's sort of like looking at tree rings, only a little bit more precise and certainly a lot more real time. Anyway, the point being, if the index, the integration of these two numbers is positive, today's value 13.91, pretty positive, that suggests higher pressure in the Pacific. If it were negative, that would suggest low pressure in the Pacific. And we look down, well, we were up at 2631, pretty high values, so maybe the inactive phase of the MJO. And then we were at a little bit lower values. I mean, notice there's a lot of variability in all this, maybe in the early to mid-August time frame. So maybe active phase, inactive phase, who knows, maybe kind of neutral here. So we take 30 days of data, average it out. Today's value, 10.7, and the trend has been weekly up, but pretty stable. I mean, just going back for a whole month, we haven't gone up or down. That would probably be steady state La Nina, but we'll know better by looking at the 90-day average. Today's value plus 11.44, nowhere near negative range. And it too, look at it, it's just stable as a rock. Yeah, maybe 13.08, but 1 or 2 points is nothing. We need to see all these start heading downward, and we don't expect that to happen until maybe we get to October. Remember the model, the long-range CFS model? It said westerly anomalies moving into the West Pacific in the mid-October time frame and getting a foothold. Maybe that's when we'll see some changes here. Here's the 30-day SOI graphed out. You can see back in 2020, the spring of 2020, that was the last time we saw anything that resembled a El Nino or even neutral. Since then, we've been on an upward climb. The upward spikes are the inactive phase of the MJO. They've dominated the weaker active phases. Yeah, we had a pretty good push there, but then back. You can see, just draw a line through that, heading up. But here we are in July. Things settled down, and we've been hovering right around 10 for, well, what was this? That's July, so August and September, maybe almost 2 months now. That's kind of a good sign, but you can see it did something like that here and kind of here. So we don't know where this is going to settle out, but the hope is that maybe it creeps up a little and then starts heading down from there. Let's go look at the forecast. So this is a sea surface temperature forecast for the official El Nino monitoring region, the Nino 3.4 region, that area on the equator south of California out to about the date line. The CFS model is pretty representative of all the other models. They're all pretty much in agreement. But let's go back in time just to get a sense. Okay, October 2021, half a degree is the La Nina threshold. We've been below there from October to January this year through April, July, and today we're somewhere right around in here. The forecast, the dotted line, has temperatures falling. Now, this is the raw data, going down to almost 1.5 degrees. That is clearly La Nina territory, deep in La Nina. But then somewhere in November, magically, the model shows a sudden increase, and by, when was that, February, mid-February, we're out of La Nina territory into neutral territory and maybe heading up even from there as we get into the fall. That would strongly suggest some sort of significant active phase of the MJO and Kelvin wave activity because, well, let's talk about this. This is sea surface temperatures rising steadily somewhere in the November, December, January time frame. That would suggest that somewhere right around in here, some strong Kelvin wave activity would have to help, and that would create a Kelvin wave. It takes 3 months to make it across the Pacific to Ecuador. Then it has to upwell, and then it starts drifting, get caught by the trades, pulled back into the Nino 3.4 region. So somewhere in January timeframe. So this model, it's the same model as the one we saw before that suggested all the westerly anomalies building in October and that sort of time frame. That's what this is all hinting at. Now, this is the raw data. This is the corrected, PDF corrected data. That previous data is biased kind of low, so there's some process that NOAA uses to say, well, this is probably more likely the correct result. And this is reflected by many, many other models as well. I think we talked about that maybe 2 weeks ago, something like that. In fact, in the next 2 weeks, there will be an update when we do the next video, not next week, but the week after that. We'll have data from all the other models to see if all this lines up. Anyway, the point being, all right, so here we are. Temperatures 1 degree below normal. That's what we're seeing. Maybe a little bump down to 1.5 degrees. That's not so bad in November. And then from then on, we're off to the races with temperatures heading upwards. Here is the different forecasts from the CFS model for each month. I'm not going to really drive into this, and they're tiny, but you can see cold water in September, October, November, it starts to fade. As you get into December, here we'll open this up, you can see temperatures definitely starting to moderate. And then by January, yes, there's still cold water, but not nearly as deep. The whole mass of it is supposed to collapse with neutral temperatures setting up. And then when you get into February, La Nina is gone. We're certainly not in El Nino, but La Nina is gone, and a neutral temperature regime is to set up. So if you read the news, and there's been a lot of hype the past couple of days, a third year of La Nina is coming, locked in like it's guaranteed to happen. And you look at the data from every major model across, not just in the U.S., but over in Europe, in Japan, Canada, you name it. Everyone is suggesting at a pretty good confidence level that comes somewhere in the late fall, something's going to change. Now, we will have La Nina conditions through fall, and I think fall, from a surf perspective and from a rain perspective, is going to be pretty horrendous. I mean, we're already nearly in fall. I think fall starts in, 10 days, the 21st of September, and it goes into December 20th, right? And during that whole time, this transition is supposed to be happening with cold water on the equator and at depth, but warm water, we suspect westerly anomalies building across the Kelvin wave generation area, creating Kelvin waves that theoretically should push under the equator and start gurgling up off of Ecuador, probably in the December-ish time frame, something like that. And then that water drifting, getting caught by trades, drifting into the official El Nino monitoring region, the Nino 3.4, as we get into January and February. And by then, the jet stream will pick up on that pretty quickly, and then instantly you'll see, hey, we got a better storm track. The jet stream looks better. It'll probably be split this fall, pushed way off to the north in just a fragmented mess. But then somewhere in the late January, early February time frame, a little bit at a time, the jet will get more organized. You'll start having a series of storms. And as we get deeper into February and March, it's like, hey, winter is here. You'll start getting snow, theoretically, as those easterly anomalies evaporate over the East Pacific. And we could be back in business. But the operative word here is could. Nothing is guaranteed. Don't believe a model 4 days out, much less 3 months out. But it looks like somewhere around Halloween, we'll say October 16th to the 30th, there should be a transition starting to develop in the far West Pacific. We talk a lot about the MJO and westerly anomalies and da-da-da-da-da. I know you're sick of hearing it, but that is what gives you the 3-month early warning of what's going to be happening at the surface and surf-wise well in advance. So if you see that happening, then you know we're going to be in good shape as we get deeper into winter. But we're still a ways off from that. For the immediate future, hey, small southeast swell is working its way towards California. Actually, before that, New Zealand swell. poised. It's been hitting Hawaii, nothing huge, shoulder, head high, something like that. That's supposed to work its way into California, southern, northern California here in the next couple of days. That'll produce some surf. Then after that, a bout of southeast Pacific swell, more south angled, like 190 sort of thing, into mainly for California. While that's happening, come Wednesday and Thursday of this week, a new gale builds off of New Zealand. That'll take, a week to get to Hawaii and 8 or 9 days to make it into California. And then after that, secondary fetch over the central South Pacific. So it's basically just one after another. Nothing huge, but rideable waist to chest high, maybe a little bit more type surf in varieties of locations that are well exposed to the south. All right, so things looking positive, not great. Big decision point coming from for the atmosphere in October. We're very interested to see how this is going to play out. Don't necessarily believe the hype in the press just yet, but we could be proved wrong, and the models could all be wrong, and we could be in a deep La Nina pattern the whole way through winter. So who knows? We'll have to watch, see what happens. All right, if you enjoyed the video, give us a thumbs up, like and subscribe. And you get automatic notifications when we post the video. Again, no video next week, but the week after that and beyond, there should be a fair number of them coming, and hopefully with good news for all of us. So that's it for this week. We'll do it again 2 weeks from now. Stay safe, get some waves, and we'll see you in 2 weeks. Thanks for watching.